Before I go into explaining what is dynamic panel data, we need to understand one very important concept that is called endogeneity. And related to that is called instrument variable. Okay. These are the two things that we need to understand. Okay. So someone wrote something in the chat, is it? Let me check that. Yes, sir. Okay, fine. So let me start, and I would like you to interact as and when required, right? Right. Proceed. What is endogeneity? Before I speak on endogeneity, can anyone tell what is, or any idea you have about endogeneity?
Sir, when the error terms are correlated with the regressors.
Okay. Just a minute. Show meeting means this is how it does. Okay. Uh, again I have to share. Yeah. Tell when
When the
the
error terms are correlated with the regressors.
error term is correlated with the regressor, we say we have endogeneity problem. Technically, this definition is absolutely right. Yeah. Anyone having any other version to this? This is what we mean by endogeneity. Yes or no? My screen is being shared, right? Are you able to see my screen?
Yes, sir.
Yes or no? Yeah.
Yes, sir.
So that's the basic definition of endogeneity. But my contention is to make you understand from a layman's perspective, what is the problem if you have endogeneity? That means if you find one of your regressors is correlated with the error term, what is the problem? What problem will it create? You might say, sir, this is going to violate one of the assumptions of regression, that the exogeneity assumption is violated.
So probably measurement problems, and because we might not, because of some unobserved variable is, when we have not taken into account any variable, it goes to the error term. And when it goes to the error term, it might show correlation with the independent variable, specifically unobserved variable, which we have in case of panel data, and it causes the problem of endogeneity. So, and further, it may lead to biased estimates of the results.
Okay, so these are all technical, explanations.
Right.
But let me give you one simple scenario that will help everyone understand why endogeneity is a problem. Say, for example, you are trying to figure out how exercise affects weight loss, right? Everyone is these days conscious about their weight and wants to lose weight, right? And exercise definitely helps. But you are ignoring one important factor, that is your eating habit or diet, right? Yes or no? Even if you do exercise and if you have unhealthy eating habits, diet, then it's not going to work, right? Yes or no? Correct?
Yes, sir. Yes, sir.
Yes.
Now, if you do not incorporate your diet or eating habit into your model and simply you estimate the coefficient of exercise, that is actually capturing the impact of exercise on weight loss, then that impact is not actually the impact of only exercise on weight loss. It is combined impact of exercise as well as your eating habit or diet on weight loss. Yes or no?
Yes, sir.
Yes. So in that case, what happens? Since you have not included diet in your model, the diet is now part of what? Error term. Correct?
Yes, sir.
And that error term is impacting both your dependent variable and independent variable.
Yes.
And this is creating endogeneity because your exercise is connected with your diet, correct? And because of this connection, whatever estimates that you have got as coefficient for exercise, that is not only because of exercise, it is basically a combined impact of exercise and diet. So in that case, you are not able to isolate the impact of independent variable on the dependent variable. As a result, the estimate that you have got, that is bias. Is this concept clear to everyone? Yes or no?
Can you explain the last part, the coefficients? If I haven't taken the diet, then how the coefficient is not isolated?
Because that impact that you have captured, coefficient, is because of exercise as well as because of
Oh, hell. Okay, sorry, diet. Yes,
diet, right? But if you include diet also as one of the independent variables, then they are isolated, right?
yes, sir. Yes, sir. Yes, sir.
So if you do not do that, then it is sitting in
They
the
are
error term.
composite. Yes,
Then whatever you are getting as the coefficient for exercise, that is
yes.
actually having the impact of both exercise as well as
And
diet.
yes, understood, sir.
So this is what we mean by endogeneity problem, right? So in that case, your independent variable is getting correlated with the error term. So what is the solution? Solution is to bring the factor that you have ignored into the model, right? That's what we do. Yes or no? Is it clear? The concept
Yes, sir.
of endogeneity is clear to everyone and why it is a problem, correct?
Yes, sir.
So all are correct that when you said that it will lead to violation of the assumption of exogenity, all those things are correct, technically correct. But if you understand this simple example that I have given, then you will be able to appreciate the problem that endogeneity might create when you do regression. Okay, I hope this concept is clear to everyone. Yes or no? Please
Yes, sir. Yes, sir.
respond. Yeah, clear to everyone?
Yes, sir. So in that case, which variable is endogenous? The diet exercise or the weight loss?
Exercise is endogenous. Exercise is endogenous, right?
Acha, okay, sir.
Because diet anyway have not taken part of the model, right?
Yes, it is an arrow term. And weight loss
Yeah.
is dependent. It's not endogenous.
Weight loss is the dependent variable, right?
Acha.
So
Then the
independent variable is the endogenous variable in that case, right?
okay, okay, sir. Okay.
Clear? This concept is clear to everyone? Yeah. Okay. Now, what are the possible reasons why you get endogeneity in your model? One is omitted variable bias, which I just explained, right? There was one important variable, that is diet or eating habit, which you omitted. Because of that, there was endogeneity, right? I have given one more example. Suppose you are studying the impact of education on income. But if you omit the innate ability that a person has, which will impact both education and income, right? As a result of that, whatever coefficient that you are estimating for education and you are thinking that that is the impacts of education on income, it is actually not only the impact of education on income, it is also the impact of what? The innate ability that particular person has. Yes or no? Yes or no?
Yes, sir. Yes, sir.
Correct? So this is also another example of omitted variable bias. But if you include that innate ability as one of your variables in the model, then this can be sorted out, right? But it might create further problem because it is unobserved variable. So you'll have to deal with that, a dummy variable and all those things. But this is one of the sources of endogeneity, that is omitted variable bias. I hope this concept is clear to everyone. Yes or no? Should I proceed? Yeah.
Yes, sir.
Yes. Okay. Please make sure that you are getting it. Okay, good. Second is simultaneity, right? This is often we overlook. Simultaneity can create endogeneity bias, right? What do I mean by it? The classic example is the price and demand relationship, right? Higher prices reduce demand. We all know that. But on the contrary, we can also say that high demand can also drive up prices. Yes or no? Yes or no?
Yes, sir.
So both the way it can happen,
Yes, sir.
correct? Right? So if you ignore this, that might also create endogeneity problem, right? So we have to be very, very careful about it. And these days, reviewers are very, very particular that you make sure that your model is free from simultaneously bias. Now you might say, sir, how do you do so? You do the reverse causal link test also, right? So suppose your main model is y is a function of x, controlling for certain variable. You also show that the reverse is not true. Okay, that is x is not a function of y, right? So that is what we mean by reverse causality test, or you are making your model free from simultaneity bias, right? Okay. The other third problem that might create endogeneity is the measurement error. What do I mean by measurement error? Say, suppose in that example, I am trying to measure study hours, right? An impact of study hours, say on some say exam score or something like that. So you are surveying a student and you are asking that in last 1 month or 1 week, how many hours you studied. So that student makes a guess, which is not correct. And because of that, there may be underestimation or overestimation. So here the variable itself is incorrectly measured. This might also create endogeneity problem. Okay. So generally this we will assume in our research work, we will assume that the variable is kind of correctly measured, but there is no guarantee that it is correctly measured. If you are taking the data from some, say, third party source and all that, we kind of assume that it is they have taken care of all those issues. But the other two issues, that is the omitted variable bias and reverse causality, can create lots of challenges in modeling because of the endogeneity. Okay. So since endogeneity is a problem, and how to get rid of this problem, the answer lies in what we call instrument variable. The answer lies in instrument variable. Instrument variable can help us solve the endogeneity problem, right? So what is an instrument variable? So
So,
just apply your mind and tell what is an instrument variable. What should be the characteristics of an instrument variable? Anyone? What should be the characteristics of an instrument variable? No
So,
idea.
like any other independent variable, there should not be any sort of correlation, but the impact is very much visible.
Okay. Any other points?
Yes, sir. It should not, it should be related only to the independent variable, to the dependent variable, and not to other regressors.
Okay. Any other point?
Variables come from the lagged values of existing variables.
Is it? So instrument variable must be strongly correlated with the endogenous independent variable, because you are going to substitute that endogenous variable with the instrument variable. So it must have strong correlation with that endogenous independent variable, but it must not be correlated with the error term or directly affect the dependent variable except through the endogenous variable. I will give you one example. This concept will be clear because with example you understand things better. So let us talk about this particular problem, that you want to study the effect of education on income, right? And you are concerned with a very basic regression model, y is equal to beta naught plus beta 1 x is the error, right? And you have a concern that x may be any question anyone has?
Endogenous variable is the exercise which we have added.
Sure.
The exercise
Exercise was endogenous variable, yes, in that
Okay,
example.
so
Yes.
we want what is the other one? BI.
Now, in this case, we are having different variables. Say, for example, in this case, you have X is actually education and Y is income in this case, the example that I am giving. And X is what? X is endogenous. Yes or no? X is endogenous. Why X is endogenous? Anyone? Because I have not taken into consideration the ability, innate ability, right? So whatever beta 1 that I will estimate from this regression, that is not solely the impact of X on Y. It is also showing the impact of the other variables that are lying in the error term, right? Correct? And this endogeneity you can say maybe because we have omitted some important variable from the model. So for example, I have given one example of ability of the person that we have not taken into consideration. Or there could be a reverse causality problem also, because we can also say that higher income families might provide more education. So it is not that Y is a function of X. X can also be a function of Y, because that is very much true. How much education that you attend, that depends on how much income you have, right? Yes or no? Correct?
Yes, sir.
Yeah. So in this case, endogeneity can be from the omitted variable bias, or it could be from the reverse causality or simultaneity, right? Now, what is the solution? The solution is you have to replace X by some variable which is strongly correlated with X, but not correlated with the error term or Y. Correct? So you can think of any good substitute that can be used for X. I have given one example: distance to the nearest school. Say, let us call that as Z, right? That can be an instrument variable. It is strongly correlated with X, right? It is strongly correlated with X. But if you apply your mind that it is not correlated with, what you call the either ability or income. Yes or no? Yes or no? Are you
Yes,
able to
sir.
understand what I'm saying?
Yes, sir.
Yeah. So distance to school affects education, because closer schools includes. So if you have schools to your nearby place, then you are more likely to go and attend the schools, right? So it is highly correlated with X. But distance to school does not directly affect income through education, right? So this is the basic definition of an instrument variable. That means it must be strongly correlated with the endogenous independent variable, but it must not be directly impacting the dependent variable through education, except through education. Obviously, it will indirectly impact, because since it is impacting X and X is impacting Y, that indirect impact will always be there. But there should not be direct impact on Y from Z. Is this point clear to everyone? Yes or no? So
Yes.
if you are just a minute, if you are in a position to identify good instrument variable, then this endogeneity concern can be very well addressed. But it could be a very, very challenging thing to do, because having a very good instrument could be a challenge. That is why we often use the lag variable of the endogenous independent variable as its instrument, because in that case we do not have to look for an instrument. The lag could be its instrument, right? And that is what this is the idea that was further worked on by Arellano and Bond, and this whole concept of system GMM, and then different GMM, and then system GMM came into picture. So it started with endogeneity problem, then it was started economists, or the economists started looking for instrument variables, and it was a challenge to figure out instrument variable from outside the model, then they started, figuring out how could they use the information that is already there in your sample or in your data. And then they came up with the answer that can we use the lag variables of the endogenous variable as the instrument. Now, someone wanted to ask me some question. Please go ahead and ask.
No, sir,
Any
no
questions
question.
at
I
this
have
point?
understood.
Sir, so
Yeah.
that means introducing the lagged values of X will resolve the problem of endogeneity.
May solve the problem of endogeneity, but if you can get an alternative variable, then it will solve the problem better. But if you cannot do that, then you can take the help of lag, right? You
Okay,
can take the help of lag. So we will, because in system, difference GMM and system GMM, we do not use the instrument variable from outside. We take the instruments from the inside, but the concept remains the same, because I'll go to now difference and system GMM. But before explaining what is instrument variable and what is endogeneity, I cannot jump into it. That's why I'm giving this example, right? So this is the ideal way of looking for instrument variable. Like for example, in this case, we are instrumenting X by Z, and X is education and Z is distance to nearest school. This is a very good instrument. But is it really possible when you work on research paper that each endogenous independent variable, for each endogenous independent variable you will be able to figure out one good external instrument, which may not be possible. In that case, what is the way out? Way out is to use the lag, right? We use the lag, because if X and Y at level may be correlated, but as you go back in time, that means lags of X are less likely to be correlated with error, right? If at all, say level 1 is correlated, say lag 1, so you go for lag 2, right? So the possibility of correlation goes down as you take higher lags, right? So that is an alternative approach to figure out what the instrument variable could be. Best is to figure out something from outside the model, outside your this thing from your data set, and then you talk about that, but the model that you have or the variable that you have. Beyond that, any other variable, if you can figure out, that's the best. But if that is not possible, then we should go for the lags of the independent endogenous variable. Up to this, are you clear? Yes or no? Please.
Just one question, sir.
Yes, please ask.
So the point here is you are trying to say that an instrument variable should be correlated with the exogenous variable, but it should not
No,
be
endogenous variable. Endogenous
variable, but it should not be correlated with the dependent variable.
Yeah, dependent variable and error term.
Error term. Sir, then
Because dependency,
yes,
just
sir.
a minute, your error term is at the end of the day is what? The residue of the dependent variable, right?
Correct, exactly, sir. Yeah.
So yeah. Now continue. Yeah.
Yeah. So the point here is that multicollinearity thing, are we bringing it here when we say this instrument variable should be correlated with with X? So
Because X will be replaced by that variable, then I am not adding to the multicollinearity problem.
Okay. Fine.
Right.
Getting it, sir. Getting it.
It's not that you include both X and Z. No, not at the same time. Right?
Yeah. Okay.
Correct?
It could also be a moderating variable in that case, in case if we are sort of.
No, moderating variable in that case, then you have to use interaction.
Okay.
So to multiply one variable with another, right?
Okay,
and that multiplied variable will be the regression. Then you will have moderation, right?
Sure. Oh, right.
Okay.
Right. Thank you, sir. Thank you.
Is this point clear to everyone? Yes, everyone got the idea of instrument variable. But for our purpose, for panel data purpose, we will rely on lag of the endogenous variable for instruments. We will not look at any other variable. We will look at, these are called internal instruments. What is called internal instrument? When we use the lags of the endogenous independent variable as instruments, then these instruments are called internal instruments. Is it clear? Can I proceed? Yes or no?
Yes, sir. But the dependent variable can never be an endogenous, no, sir.
Dependent, why? That is, see, it can be if you are using a reverse causality, right?
Okay. In that case, when the
Yeah,
x will the
correct, correct. Then X becomes dependent and Y becomes independent, right?
then, sir, why do we use the lag of dependent in that case? Like I have seen in some. Maybe you will be covering that thing in the.
That I'll cover. I'll cover. See, I'll cover that. But first, understand this concept. I'm coming to that. That
Okay, sir.
dynamic panel, we will use lag, and why we use lag, and all those things I'll cover. But first of all, up to this, are you clear?
Yes, sir. Yes, sir. Clear, sir. Clear,
Yes.
sir. Thank you, sir.
So, what is the takeaway from this discussion to the dynamic panel data is this: that if there is endogeneity, that is a problem because it is violating one of the assumptions of linear regression, that any regressor must not be correlated with the error term, right? So to address this problem, we take the help of instrument variable, right? And the instrument variable ideally could be any other variable which is strongly correlated with X, but not correlated with Y or the error term. But for practical purposes, for research work, we may not have, good instruments. Like in this case, we have found one, but we may not find. So in that case, what we do, we take the help of the lag of the endogenous variable and treat them as instruments. Okay. Can I proceed now? And we will take this, knowledge forward and apply it in the dynamic panel data models. Okay. Can I proceed now? Yes or no? Is it clear?
Yes, sir. You may proceed.
Yes. Now, dynamic panel data model. Very, very interesting topic, right? So can anyone tell me what is meant by dynamic panel data model? And don't you think panel data itself, by nature, it is dynamic? Because when you talk about cross-sectional data, it is, I'm trying to capture variability across cross-sectional units at a given point in time, right? Yes or no?
Yes, sir.
And in case of time series data, we are capturing the variability over time for a given cross-sectional unit, right? That is the definition of time series data,
Yes.
right? Yes
Yes.
or no?
Yeah.
And panel data is combination of both. So in a way, I am covering both the cross-sectional heterogeneity as well as time series heterogeneity, or cross-sectional variability as well as time series variability. So don't you think this, by definition, panel data is dynamic in nature? What is your answer? Yes or no?
Yes, sir.
So
But-
this is a common, confusion that most of us have, that we think that this is the definition of dynamism.
So
Right?
dynamic
But-
means having the lags of the
Yes.
dependent
But
variable.
the actual meaning of this dynamic panel data is when you have lag of the dependent variable as one of the regression, then that is called a dynamic panel data model. If you have lag of the independent variable, that is not a dynamic panel data. Dynamic panel data must have the lag of the dependent variable as one of the regression. Is this point clear? Yes or no? Is it clear? What is dynamic panel data model? It is a model where you have lag of the dependent variable as one of the regression. And that model can also have lag of the independent variable, right? That is not the concern that we have. We are bothered about whether we have the lag of the dependent variable as one of the regressors or not. And I will explain why this is a concern. If we have that sort of a model where one of your regressors is the lag dependent variable, then it is a cause of concern. Can anyone tell what is the cause of concern if we have lag of the dependent variable as one of the regressors? Before I show you the answer, anyone? Why lag of the dependent variable, if we include in the model, it is a concern? Anyone?
Sir, because the current year's variable is dependent on the previous year. So any decision relating to the current year, we'll have to rely on the previous year.
That's fine, but what is the problem in it? If we treat the lag as one of the regressors, what problem will it create? Will it create any problem?
Autocorrelation?
Correlation or anything else?
Multicollinearity might be.
It will create the problem of endogeneity. It will create the problem of endogeneity. Why? Because your lag dependent variable is going to be correlated with your error term. And your lag dependent variable is one of the regressors. And if it is correlated with the error term, that creates multicollinearity problem, endogeneity problems, right? Now, why? Why your lag dependent variable will be correlated with the error term? Anyone? Can anyone tell? Let me give you a very simple explanation. Mathematically, I will show a little bit of it. I will not get into details of it because that is not required. But intuitively, you can understand why there will be endogeneity problem. See, what is error term? Error term can also be expressed as the dependent variable minus the predicted value of the dependent variable from your model. Can we say that? Yes or no?
Yes.
Yeah.
Correct? I repeat, error term or residual is nothing but dependent variable minus whatever is the predicted value from the model. That is called residual, right? Or the error term. That is another way of looking at error term. So if that is the case, your error term depends on y, depends on your dependent variable, correct?
Yeah.
Yes or no?
Yes, sir. Yes, sir.
And if your
Because
error term depends on dependent variable and your dependent variable depends on its lag, so dependent variables lag and the error term both are related. So they are correlated. Yes or no?
Yes, sir.
Yes. So
And
if that is the case, then you have landed in what? Endogeneity problem. Is this concept clear to everyone? Yes or no? Little tricky, but think for 30 seconds, you will understand what I'm saying, right? I'm saying error term is also known as the residual, is nothing but, say, y is my dependent variable, y minus predicted value of y from the model, right? So I can say error term is a function of y and the predicted y, right? So it means error term depends on y, and y depends on its lag because you have written y as a function of its lag plus other regressors. So in a way, we can say that the error term is also depending on lag of y. So they are correlated. And since you have put lag of y as one of the regressors, so that regressor and the error term are correlated. So you have landed in endogeneity. Is this concept clear to everyone? Yes or no?
yes, sir.
That
Yes.
is why we speak so much that, if I add the lag variable of the dependent variable in my in the independent list as one of the regressor, then it will create endogeneity problem. So this is the precise reason why endogeneity is created if you include the lag of the dependent variable as one of the regressor. And now just apply the knowledge that I gave, or we discussed the point that we discussed. So since it is creating an endogeneity problem because of exclusion, because of inclusion of the lag as regressor, you will have to look for now what? You will have to look for
Instrumental variable.
Instrument variables. And what is the easy to go for instrument variable?
Another
You
lag.
use lag.
Yeah.
Yes, you use the lag, right?
Yes,
So
sir.
now are you able to connect the dots?
Yes, sir.
There,
Yes, sir.
why I was explaining endogeneity, then instrument variable, and how it is connected with the dynamic panel data model, right?
Yes, sir. Yes,
So
sir.
in this case, I will not look for any variable outside the model. What I will look for as instrument? The lag of the independent, the lag dependent variable, right? Because it is creating endogeneity problem. Is this concept clear to everyone? Please tell me yes or no. Otherwise, I will not proceed if this part is not clear.
Yes, sir. Yes, sir. It is clear, sir.
Is
But
it
sir,
clear?
but
Yeah.
sir, if we use a lag variable as a regressor, lag variable is dependent as a regressor, then for that is endogenous variable, we have to use another lag
So
as an
suppose
instrument
your
variable.
y t minus 1 is your lag, first lag.
Yes, sir. Yes,
You
sir.
can use y t minus 2 or higher as the
Instrumental
instrument
variable.
variable.
Okay,
Yes.
sir. Understood, sir. Understood, sir.
Understood? Okay.
Yes, sir. Yes.
Okay, very good. Chalo. So if you understood this much, the basic intuition is now clear. Because anyway, mathematical derivation is beyond our reach. Correct? This it's quite complex, and we need not get into also that. But we must understand the intuition behind these models. Why we are taking the lags as the instruments, right? That is what you have to first of all understand. And why the instrument is there? Because there is endogeneity. And why endogeneity is there? Because error term and the lag of the dependent variable are correlated through the dependent variable. Okay, I hope this is clear.
No, just
Okay.
one question.
Yeah, please
If
ask.
we use multiple lags, will it address the endogeneity problems? I mean, one lag, you say, yes, there is an endogeneity issue. So if it goes multiple times, if it goes more than one, let's say we are using 2 or 3 lags. So will that sort of correct the endogeneity problem?
Maybe, but it is very difficult to.
Okay.
I have seen models where we have both 1 and 2, but you cannot straight
Okay.
away jump into 2 without taking
Okay.
1.
Okay.
Because later on you will get to know that one of the conditions of these, one of the diagnostic tests of these models, whether you talk about system GMM or difference GMM, that first order autocorrelation must exist
Okay.
and second order autocorrelation must not exist, right? So if you drop the first lag itself, then so you are not going to meet that assumption, right? That test.
Yes,
So
yes.
you can have both, but you cannot directly jump to 2 without taking 1. Okay.
Yes, getting it.
Got the point? Okay.
Thank you.
But it's very rare to see both, because
Okay.
that will have challenge, because if you have two endogenous variable in one go, so that might lead to too many instruments. So that is called instrument proliferation problem, right? And ideally your number of instruments should be less than number of cross-sectional units.
Okay.
If you read the Rudman's paper, so though there is no hard and fast rule, but these are kind of a rule of thumb that good research papers they look at. So in that case, or many times they ask you to report, so how many instruments you have used and all. So in Stata, it is reported very well. In R, it is not separately reported, but many times they might ask for it. So in that case, you have to ensure that you have used your lags very judiciously, so that you do not end up in instrument proliferation problem. It's too many instruments, okay? And that might also lead to a problem of overfitting. Your Sargent test, p-value for Sargent test might be very close to 1. So I'll talk about all these things. That is called problem of overfitting, right? So these issues might crop up later on. Okay. So I hope this part is clear. Everyone understood, why including the lag might create endogeneity problem and how to sort out that particular problem. But having understood that, now let me go back one step, go one step backwards and ask you, why to use dynamic panel data? Why to complicate life by adding one lag as one of the regressors? And we know that if we add lag as one of the regressor, we are getting into endogeneity problem. Even after knowing that we are getting into endogeneity problems, still we do it. Why? What is the logic? Can anyone tell what is the logic? Why are we using lag of the dependent variable as one of the regressors? What is the logic? Because whenever you use dynamic panel data model in your model, first of all, you have to justify. First of all, you have to justify why a dynamic panel data model is appropriate in this case. Without that, if you do not justify, simply you know the codes of running system GMM, two-step system GMM, jumping in the air, and you run the model and report it. No, it's not going to be accepted. You have to first give the logic. If you read the Arellano and Bond's seminal work, and after that, we got that technique of difference GMM. First, they have explained why they have used dynamic panel data model, why they have included the lag of the dependent variable. So that is a must. Why that is a must? Because if you are using dynamic panel data model, your OLS is out of context. You cannot use OLS. You will have to use GMM, generalized method of movement. And please understand, OLS is the dark horse of econometrics. OLS is dark horse of the econometrics. Always remember that. Unless we have no other option, we should not deviate from OLS. Because at the end of the day, here what you are doing, you are using instruments and all those things. So instrument can never be a perfect substitute of the main variable. Yes or no?
Yes, sir.
Yes, sir. Yes, sir.
In OLS, you are using original variable, right? Here you are using instrument. So naturally, you have to compromise on some sort of efficiency and the robustness of your model, right? So you have to have enough justification for using dynamic panel data model, because in that case, you cannot use OLS anymore. You have to go for GMM. So we might think that, oh, GMM means superior technique. Not necessarily. Because you have to use instruments. So it is an indirect thing, right? You are not using the main variables, correct? You have to understand that. So you must have strong justification for using the dynamic model in the first place. So what is the justification? So say,
Correct.
for example, my dependent variable is profit, and I want to use a dynamic panel data model. What could be the justification? Anyone?
Sir, I can give with my own example. For example, I do research on stock market. So,
Okay.
although the stock prices are impacted by different variables, but previous day stock prices also get impacted, also impacts the current stock prices. So, if we have enough theoretical justification that previous lags are also impacting the current stock prices, I think we should include that into the model. So that is
Okay.
that is why I generally go for dynamic models only, because
Okay. Now I will give you a very, very concrete, explanation why one should go for dynamic panel data model, provided they are working on certain types of variables. Say, for example, if your dependent variable is profit or profitability, right? You should go for dynamic panel data model. Why? Because if you believe that past influences the present for the outcome variable that you have taken in your study, then you have to go for dynamic panel data model. But only stating this is not enough. You have to give enough justification. So, for example, I believe that current profit is often, profits often depend on past profits. That is, PIT depends on PIT minus 1. But you have to tell me, or you have to give the reason why. Due to, number one, persistence of success or failure. Firms that are profitable in the past are more likely to maintain that profitability due to factors like they have already established customer base, right? That is not going to change overnight, correct? If they are enjoying competitive advantage, that is not going to change overnight. If they are having a particular market share, that is not going to change overnight. If they are enjoying positive momentum or operational efficiency or reputation, that is also not going to change overnight, right? It means what? If they have succeeded in past, that is going to persist. Similarly, if they have failed in past, that is also going to persist, because overnight it's not going to change, right? Yes or no? Because at the end of the day, profit or profitability, whatever you call, these are all what? Measures of performance. So if you performed yesterday better, so today you are likely to perform, at least in that range, right? Because today's performance is going to be impacted, because we often say, na, my mood is not good today. That means how I perform today, it depends on, what happened yesterday, right? Correct. So if that is something that you can, theoretically establish, then you can do that. Financial or resource constraints. Firms use past profits to fund investment or expansion, right? So last year, how much profit I made, on that, it will depend how much further investment I will make. And from that, I will make profit, right? So in a way, this year's profit is going to be impacted by last year's profit. If last year's profit was less, I could have, I would have invested less, and that would have resulted in lesser profit, right? So connection is there, very much there. So you have to give adjustment process. Whenever you do something, the impact is not immediate, rather it is gradual, right? If you do something, suppose you launch a new product, are you going to reap the benefit immediately? It might take a couple of years, or at least a year, to actually see the benefits, right? So there is some adjustment process, because things do not get adjusted if there is some change in one of the key variables from the company's side. The impact of that variable on profitability will not be immediate, right? So there is some adjustment process, right? Learning and experience. Firms learn and improve based on past successes and failures, right? So that is also going to be one of the reasons why your current profit is going to be based on previous profit, or going to at least partially going to be depending on market signaling. This is very, very important, right? Past profit signals a firm's financial health to investors, lenders, and stakeholders. So if you know that this company is doing well, you will be ready to give funding to that particular company at a favorable rate, right? If you know that the company is not doing well, you will probably ask for higher rate of interest for funding, correct? Yes or no? Because high risk is involved, correct? So if the company is sending positive signals through higher profit in last year, that is going to impact current year's profit also, because they are going to get funding at a cheaper rate. So there are n number of reasons that you can cite, right? Because I worked one paper, I told you that impact of ESG on banks' profitability. So the reviewer asked me in the first review, I did not explain why dynamic panel I have used, because I was kind of very, very enthusiastic and confident of the newly learned skill of running a system GMM, steps system GMM model, that means data, and also I was very much confident. And without explaining why dynamic model, I sent the paper, and the reviewer wrote half a page comment on that particular point. So I had to explain each bit of it, why ROA is persistent in nature, and why dynamic panel data model is applicable, right? So this is a point that you have to be very, very careful about. Before you apply dynamic panel data model, you must have strong theoretical justification for using it, because in dynamic panel data, you will not be able to use OLS because of the endogeneity problem that will creep in because of the lagged independent variable. So you should have solid justification for deviating from OLS. Okay, please keep that thing in mind. Okay, so I think we have spent enough time on this. So what is the main challenge in dynamic panel data model? That is endogeneity. I have already explained, right? And I have already explained why endogeneity will be there. So mathematically also I have shown it here. So I can just keep this. Now, one of the things that we can do, we can take differencing. If we take differencing, then this mu y will be eliminated, because that is what? Time invariant, some specific factors, heterogeneity, unobserved heterogeneity, right? That is what we called alpha I, same as mu y, right? Same thing. So if I take differencing, this will be eliminated. Yes or no? Yes or no?
Yes.
Yes.
So you see, this can also be a cause of endogeneity, or this might cause the errors to be related with the regressors, correct? And by differencing, we can eliminate it. But even after differencing, still the endogeneity problem will not be solved. Why it will not be solved? See, suppose this is the after differencing, this is the equation we get. This is the first difference equation, correct? In this case, still I would say
I'm not
this.
understanding from here. Can you please go
Ha,
one
ha,
step
ha.
back?
Tell me which
explain
part
this
is not
again.
clear. I'm saying from this, so suppose these are the two equations. One is for yit and one is for yit minus 1, right? So just see the pattern, the way the equation is written. So what are these numbers basically? So this is the dependent variable, this is the lag of the dependent variable, right? And this is the independent variable, correct? And this is the farm specific, unabsorbed heterogeneity. And this is the normal error term, correct? Is this equation clear?
Sir.
Okay. Now, instead of writing y1 it, if I write yit minus 1, what this equation will look like? Now, this will become t minus 2, this part. Yes or no?
Yes, sir.
And this will become what? xit minus 1, because it was it, right? And this is time invariant, so it will remain as it is, correct?
Sir.
And this will become what? This will become epsilon I t minus 1. Okay.
Okay.
Now you tell me, in this case, this value, this yit minus 1, is it correlated with eit minus 1? Yes or no? Just think for 30 seconds and tell.
Yes, sir. You had
It is
explained
correlated,
this.
right?
Yes, mhm.
Correct?
Yes,
Is that
sir.
clear? It is correlated. I have already explained that logic, why it will be correlated
Yes,
in the
yes,
very
yes.
first place before showing this.
Mm.
Okay, now correct? Understood?
Yes, sir.
Yeah. So it is correlated. Now I say this correlation, see, because if you add these two terms, that is called composite error term, right?
Yes,
If I
sir.
add these two terms, so a part of the composite error terms can be eliminated by simply taking the difference. That means if I do yit minus yit minus 1, then this mu and this mu will be cancelled. That is what we are talking about. Is that clear?
Okay.
Because both are time invariant. So that is what we have written in this equation. Right? In this equation, we have no more that mu I, right? Because it is eliminated. Right?
Okay.
Yes or no? Hello?
First equation once again.
Yeah. See, if these two equations are there, up to this is clear, right?
Yes.
Yes. Now, if I take yit minus yit minus 1, if I do that,
Okay. अच्छा ठीक है अब समझ में आया ठीक है
ठीक है, मतलब I'm just taking the difference of both the
Yes, yes.
equation. So
Okay.
if I take the difference of both the equation, the constant factor will be eliminated, cancel.
Yes, sir.
Now that is what we have written here. So delta yit is equal to what? Yit minus yit minus 1, right? Will be equal to delta yi comma t minus 1 plus beta delta xit plus delta eit. That is this just the first difference. If I take all the variables, first difference, this is the equation I am going to get, right? Yes or no?
Yes, sir. I
Clear?
understood.
Understood?
Yes, sir.
Understood or not? So I am not in hurry. Please tell if it is
Yes,
clear.
sir.
Then
Yes, sir.
now, even after doing this, still your delta yit minus 1 will be correlated with delta epsilon it. Going by the same logic. Yes or no? The way EIT and YIT minus 1 are correlated, going by the same logic, delta YIT minus 1 and delta EIT will still be correlated. It basically means even if you remove the farm specific unabsorbed factors by differentiating or by demeaning, which we do in fixed effect model, still the correlation between the lag dependent variable and the error term, whether they are in level form or in difference form, exists. And this bias, because of this, correlation between error term and the lag dependent variable, whether they are in difference form or in level form, the fixed effect estimates will be biased. Fixed effect estimates will be biased. And this bias is called nickel bias. This bias is called nickel bias. This bias is called nickel bias because it is named after economics Nickel, who first came up with this explanation that in fixed effect model, we cannot use the lagged dependent variable as one of the regressor, because we might tend to think that if we take the differencing or if we do the demeaning, anyways, I'll be able to remove the fixed effect part. That is true. But even after differencing or demeaning, we are still left with that correlation between the lag dependent variable and the error term. So that is why in fixed effect model, we never ever use the lag dependent variable as one of the regressor, because it will create a bias, and that bias is called nickel bias. Okay. Is it clear? Yes or no? Anyone understood or not? Yes. Is it clear? Is this concept clear to everyone?
So, like these fast differencing, you are talking about the fixed effect. The fixed effect fast difference, or what, sir?
Fixed effect fast differencing.
Yes,
What
yes,
we
yes.
do in fixed effect, we get rid of those alpha I, which is same as mu
By
I,
yes, sir, by taking the
by taking either taking difference or by demeaning. Because if
by
I take
demeaning.
difference, then also it will go away. If I
Yes,
take
by
demeaning
demeaning, that is
approach,
also
then
good.
also it will go away, because
Yes,
these are
sir.
time invariant.
Yes, sir.
So whether you do demeaning or if you take differencing, both the ways they will go away. But
Yes,
even
sir.
if they go away, still the endogeneity problem remains. That
Yes,
is
sir.
what I'm trying to say, and that
Yes,
is
sir. Yes,
called
sir.
nickel bias.
Okay, sir. Understood, sir. Thank you, sir.
Understood?
Yes, sir. Yes, sir.
And this nickel bias is of order 1 by t. It has a big derivation. We need not worry about that derivation. It is of order 1 by t. It means if your t is very small, then nickel bias will be very, very large, very, very strong, significant, very strong nickel bias will be there if your t is small, right? So how to solve this nickel bias problem? To solve this nickel bias problem, you will have to use what? You will have to use generalized method of moments, that is difference GMM and system GMM. Okay, is this point clear to everyone? Is this slide is clear to everyone, that why even after differentiating or even after removing the fixed effects from the model, still the lag dependent variable will be correlated with the error term?
Sir,
Priti, are you clear on this, or should I explain it once more?
no, sir, this point is clear, but you said that nickel bias will be very, very large in what case? When T is
T is small,
okay.
because it is 1 by t, na order is 1
1
by
by
t. If
right.
t is small, then it will be large bias will be there, right?
So what is T?
T is time, how many years data you have.
Okay, okay.
So basically, as I just told, difference GMM is a technique to be used when you have a dynamic panel data model where you have one of the regressor is your lag dependent variable, right? Okay. And it is basically designed to address the endogeneity concern that slips in because of the inclusion of the lag dependent variable, and this was contributed by Aralando and Bond, right? And how the difference GMM solves the endogeneity problem? So this is my basic equation, which is a basic plain vanilla panel data model, right? So yt as a function of yt minus 1 xt, and you have the arm specific error component and the normal error, right? Arm specific factor and the normal error. And we do what? We do the first differencing, which we have already talked about, right? And by first differencing, we remove the mu I or alpha I from the system. but that is not good enough, because even after doing this delta yit t minus 1 is still correlated with this. That means this one and this one are still correlated even after doing the first differencing. So what I have to do, I'll have to use instrument for this. I'll have to use instrument for this. Okay. So what will be the instrument for this? So that is what I'm saying. The first differencing introduces a new issue, because this is still correlated with this, because because this is also is having this term, and this is also having this term. So because of this, because this is common in this term and this term, so there is a correlation between this and this, right? That part is clear, I think. Because what is this? This is basically E it minus E t minus 1. So this includes this. No, this is depending on this. And in this equation also you will have this, right? So since both this and this are having this, so naturally this and this are correlated. Okay. So even after differencing, we are not able to get rid of the correlation, right? To solve this, what we do? We use some instruments. So what is the instrument that Arelando and Bond proposed? Is it delta yit minus 1? For delta yit minus 1, is it delta yit minus 2? That is what they proposed. Answer is no. What is the instrument that they propose? They propose lag levels of the dependent variable, right? So for this, what they are suggesting, that you use yit minus 2 as instrument, or yit minus 3 as instrument. Okay, not delta yit minus 2. So this is the suggestion that they gave. What is the suggestion that they gave? For this, you instrument lag of the dependent variable at levels, not at difference. So this is the suggestion that they gave, or in their model, this is how they used the instrumenting part. So they are saying that this should be instrumented by either this or this. Okay, because that will reduce the possibility that your instrument gets correlated with the error term. Okay, so this is basically the same concept of using the lags of your variables as dependent variable as the instruments. Okay, and we will talk about the system GMM when we will have both the lags of difference as well as lag of the level as instrument. So that is a mix of both. That is why it is called system of equation. So I'm coming to that. So I repeat again, this is still correlated with this error term, and this is going to be instrumented using these two or higher, that is yit minus 2 or yit minus 3. Okay, and yit minus 2 correlated with this. So this, since this and this are correlated, okay, this and this are correlated. Why this and this are correlated? Can anyone tell why this and this are correlated? Because this delta yit minus 1 is equal to yit minus 1 minus yit minus 2. So t minus 2 is there in this. So this and this are correlated. Okay, but this is not correlated with this, because what is this? This is E it minus eit minus 1. So 2 is nowhere there. So this and this are not correlated, but this and this are correlated, right? So this is the basic definition of selecting an instrument. Is this clear? Understood or not? Hello?
Yes, sir. Yes, sir. Getting
Yeah.
that.
Clear? Yes. Kriti, are you getting it? What I just said?
Yes, sir. Yes, sir.
Yeah. Okay. So this is how we
The
use the
logic
instrument.
is, sir, basically, can we say that the logic is the impact of previous shock fades with time? That is why it is not correlated to the current error term?
That you can say, but mathematically also you can figure out, na?
Yes, sir. Matlab, logic is like this only?
Yeah.
Okay, sir. Okay.
So since this is yit, it is a combination of t and t minus 1, right? And since this is y I t minus 1, so it's a combination of t minus 1 and t minus 2. So if it is combination of t minus 1 and t minus 2, that means this and this are correlated. But this cannot be correlated with this simply because it does not have any connection with t minus 2, right? That's the point. Okay. So I hope this is clear. Now let us proceed. When to use system GMM, and then we will do the estimation in the R. So when to use difference GMM and system GMM will come later. When to use difference GMM. So if you are working with dynamic panel data model, then you will use difference GMM. When you have small time period and large cross-sectional N, why? For small, this is good because if your data is very small, your T is very small, then as I told you, that nickel bias will be very large. That means you cannot get rid of the problem of endogeneity by simply doing the differencing or demeaning, which we do in fixed effect model, right? But if your T tends to infinity, then nickel bias will be very insignificant. So in that case, even differencing and all can help, right? That is what they are telling, but which is very rare, because most of the times our T is small, right? So you'll have to go for difference GMM, right? Okay. And if you suspect that there is endogeneity problem, and obviously if you include the dynamic, if you are working on dynamic panel data model, at least the lag dependent variable will be having correlation with the error term, and there will be endogeneity problem. So these are the conditions which must be present for using the different GMM model. And one of the important things that I told you in the beginning, that to apply different GMM model or any panel data model, first of all, you must have justification for using the lag dependent variable as one of the regressors. So strong justification has to be provided. Okay. Next is, what is one-step difference GMM and what is two-steps difference GMM? Because we will be doing all these things, but we need to understand what is it. So difference GMM also has two versions. One is called one-step, the other one is called two-step. What is one-step? One-step assumes that homoscedasticity of variance, right? And two steps assumes what? Heteroscedasticity, right? So since two steps assume heteroscedasticity, in case of two step, you will have to use robust standard error. You have to use robust standard error. This is the point I had already explained, right, when I was discussing that fixed effect model. Right?
Yes, sir. Yes, sir.
So you have to use robust standard error, correct? Otherwise, there is no other difference. That means in terms of what is to be used as instrument and all, everything is same. Only difference between one step or two step is, in one step the assumption is homoscedasticity of variance. In two step we recognize the fact that variance is not homoscedastic, it is heteroscedastic, and we use robust standard error. Okay, rest all you can understand, not that important, right? So with this, now we will go to R and do the estimation, and then after doing this we'll come back and look at some of the limitations of one step system difference GMM, and then we'll proceed to the system GMM.
Sir,
Up to this, are you okay? Still
sir,
now,
that
whatever I have discussed, is it okay with all of you? Yes
sir,
or
that
no?
one-step difference GMM should not be used because it assumes homoscedasticity, which is not there. We should always go with two-step then.
Now, ideally, two step is much more robust because it takes into consideration, it recognizes the fact that variance is heteroscedastic,
Okay.
right?
Okay.
So
But
that is
sir,
why. Hello. Yes.
yes, sir. Yeah, that basic condition of dynamic panel, that there should be heteroscedasticity problem, na, in the data.
No, that is what I'm saying. That is why
Yes, sir.
we generally use two step. One step we
Okay.
generally do not use. But if you want to understand what is the difference between one step and two step, that is why I'm explaining.
Okay, sir. Okay, sir. Okay, sir.
Because someone was asking the other day that what is the difference between two step two-step and two ways. Okay.
So this is
So you should not get confused between two-step and two ways. I will just, when I will run the code, then I will explain it better. So then it will be even more clear. Don't get confused between two ways means whether you are using Farm's fixed effect as well as time fixed effect or not. That is called one way or two way, right? And
Got it.
one step or two steps with respect to whether you are assuming homoscedastic or heteroscedastic variance, heteroscedasticity. Okay, is this clear?
Clear, sir, clear.
Yeah. So this is what someone was asking. I think Parminder
I
ma'am
was
was
asking.
asking.
So I asked in the last to last class.
Yes, yes, yes. So this is something you have to understand very, very clearly that uh, two ways means you are including both fixed, company specific or farm specific effect as well as fixed time effect. That is called two ways. And when you are talking about one step or two step, in case of difference GMM or system GMM, we are basically talking about the assumption with respect to variance. If you are assuming homoscedasticity, then it is one step. If you are assuming heteroscedasticity, then it is two steps. And as Partho rightly pointed out, is we know for it a fact that there is heteroscedasticity, so it is always better to go for two-step version. And it is much more robust than the one-step version, right? Because it is very difficult to hold that homoscedasticity assumption. But if it is the case, theoretically you cannot rule out, then one-step difference GMM will still make sense, right? Okay, clear? Yes or no?
Yes,
Can I
sir.
go to R now? Everyone
Yes,
is
sir.
ready?
Yes, sir.
Yeah. I have tried my level best to simplify the things to the extent possible. I think at least broad idea is clear to everyone. Yes or no?
Yes, sir.
Yeah. Okay. So let us go to the R Studio. So first thing is you have to set the working directory. Okay. How to set the working directory? By now everyone should know how to set the working directory. This is the fifth session that we are doing, right? Okay. So if you already have this code, you can just run this code. Otherwise, go to session, set working directory, choose directory, and then from desktop, where the file is, your FDP, right? This is the thing. So your directory is set. Otherwise, if you have the code with you, you can just click on this and run, right? So your directory is set. Everyone has set the directory? Yes or no? Yes or no? Everyone has set the directory?
Yes, sir. Yes, sir.
How to how to remove these things from your environment? Sometimes if you have too much of things in the environment, it might create an issue. So can we just you can use this Jharu to get rid of all these things, right? So it's gone. Fine. Okay. Everyone has set the working directory, yes or no?
Just a minute. Just a minute.
Yeah, please do it. Please do it. I am not in hurry. Let me make it a point that everyone has done it. Okay. So same process. Now we'll have to import the data manually. You can do that, but I strongly recommend not to do manual import. Always make use of your working directory because that's going to help, right? That's a good practice in R. So you have to you have to get this library package, that is read Excel loaded. So library read Excel, please do it, everyone. And then you have to import the data. But the data that I have shared is a CSV file. So there is a little difference. When you import CSV file, how do you go about it? Any idea? Last class also you have done, I think.
.cs.
Data is equal to read
.cs.
.csv. Read .csv, and then double quote and put your cursor in between and press on tab, it will show you all the files that are there. I want this dpd underscore demo, dpd underscore demo. Okay, is everyone able to do it?
Yes, sir.
Yeah, done. So just get the just run the code. You will get the data in your environment. Just run the code. Have you got the data in the environment?
Yes, sir.
Just click on data to take a look at the data set. Okay. So you have, how many years of data from 2000 to 2009, and you have 50 farms data for 10 years. Okay. And you have three variables. One is I is for innovation, that is the research and innovation cost. M is marketing cost, and P is profit. Okay. I have kept it very, very simple. You can always complicate the model by using few more farm specific control variables. But I just want to cover all the 4 models. That is, in fact, there will be 6 models that I will be discussing. 4 model, that is 1 steps different GMM, 2 steps different GMM, 1 step system, 2 step system, and then 2 models to define the upper bound and lower bound. One is the pooled OLS and the other one is fixed effect. Okay. So these are the 6 models that we'll run today. And the next class that I will take, in that we will work on one more research paper oriented data. And obviously we'll talk about few more papers and some more things. Okay.
Just a simple doubt. Do we have to use that sentiment or what, the robustness analysis for that is GMM also?
Everywhere it is applicable.
Okay, sir. Will you show that?
So
Or will
if you are using system GMM, that does not mean that you are free from, or you are waived from, or you did not do any sensitivity analysis.
Okay, sir.
It's not like that, right? So
Okay, sir.
what people do, even if you are using dynamic panel data model, then in either in base you use fixed, and in robustness test you show dynamic. But if you feel that dynamic is more applicable, then in base you use dynamic, and fixed in robustness you show static.
Okay,
Right?
sir. Understood, sir.
Okay, because by and large, if this dynamic model is showing positive relationship, static model should not say so negative relationship, right?
Yes.
So there has to be some, synchronization between whether it is static or dynamic, right?
Okay,
So,
sir.
So that sensitivity analysis is required for good journal. It is a must. They will, otherwise they will not publish.
Okay, understood, sir.
And not only that, also you have to have a separate measurement of, the dependent variable.
That is the issue, sir. Okay, but
So two measurements and 2 econometrics technique. That is these are minimum. Plus, if you can top up with subsample analysis, then it is, cherry on the top, you can say, right? Okay.
okay,
So
sir. Understood, sir.
I know it is easier said than done,
It
because
sounds
doing
easy,
all those
but
things is very difficult. I know that,
yes, sir.
but
It sounds easy, but it takes huge effort, sir.
a huge effort. That is why, see, one paper will take 1.5 years minimum to 2 years to get published.
Yes,
It's
sir.
very, very painful. It is very, very painful. Very, very painful. And that after doing all these things, they will make you revise at least twice. They'll say something in one go. They will not tell everything. In first review, they will give some comments. In second review, they will give some comments which they could have, given in the first thing only. So they
Revision,
will
yes, sir.
not do it. So this is how they kill time. Also, they see how interested you are. All these things, right? So many people give up, now. So they say, "Oh my God, it takes so much of time. Let us not worry about it. Let us get it published in some, C journal or something like that." Right? Okay. So I think
Understood,
the data is clear to everyone. Huh? Okay. So it's basically we are going to see the impact of this innovation and marketing cost on profitability, right? Or profit simply, because it is all are say in crores of rupees or whatever it is. That's not a problem. Okay. So let us now go and do the thing. Now, first thing that I will do is after reporting, importing the data, I will load the PLM package, right? So just load the library PLM. Okay. So, and then I will define the structure, right? Panel data structure. I'm just giving the codes in the WhatsApp. So those who are doing it simultaneously, you can take WhatsApp.
Sir,
Ah,
we don't
sure.
have firm and year in the data. We have IMP.
Hmm?
Okay, we have firm and year. Sorry, sir.
Yeah, it is there. Okay. I have given the data code. Farm and year is there. Farm is basically the company ID, right? Cross-sectional ID. Yes or no? I think this structure you are all aware of, right? Panel data structure. So just declare your data as panel data. Done? Yes or no?
Yes, sir.
Yeah. Now what I'll do, I'll just create lags, lag 1 and lag 2, two lags for each of those three variables, right? I'll create two lags for each of those three variables. So what I'll do, I'll just copy and paste this in the chat box, or not in chat box, in the thing. So please take from there and run the codes. Okay. I'll go slow. Please make sure everyone is following. If you have any question, please ask up to this. Okay. Please let me know once you are done.
So in this, we have created two lags of each variable.
Yeah. Now,
Okay.
you may see what is going on here. You see, now if you look at this data, please take a look at this. If you look at this data, you have only this I, M, and P, right? Yes or no? Only three. But if you look at this P data, now you have all these lags, right? Yes or no? And these lags have come because of this code. Which code? This code. So what I'm basically saying that in P data, you create one column with heading PL1, right? And PL2. Similarly, IL1, IL2, ML1, ML2, right? And KA is here the lag, right? Is it clear? Okay. So where to apply the lag? You apply the lag to P to get PL1, right? You apply lag 2 to P to get P lag 2. That's the meaning of this code. I think this is clear. Clear? Everyone got the code? Yes or no? And have you executed the code?
Yes, sir.
Now, one rule of thumb, not rule of thumb, this is what Arredondo and Braun proposed in their seminal paper, which got published in 1991, that all your difference GMM model and system GMM model should throw the coefficient for the lag dependent variable within a range. there is an upper bound and there is a lower bound. Anyone knows what is that upper bound and lower bound? Those who have some idea of GMM, system GMM and difference GMM, have you come across these two, upper bound and lower bound? Or if you have read that paper, yeah, anyone? What is the upper bound and what is the lower bound? So upper bound is the coefficient of the lag dependent variable if you run a pooled OLS model. That is the upper bound. And the lower bound is the coefficient of the lag dependent variable if you run fixed effect within group model. And when I say fixed effect, by default it is within group. Okay. So what is the upper limit? Upper limit is the coefficient of the lag dependent variable as per the pooled OLS model, and lower limit is the coefficient of the lag dependent variable as per the fixed effect within group model, right?
The lag
So
dependent variable, coefficient of lag dependent variable.
Lag dependent variable, that means I am talking about
lag dependent variable.
PL1.
Okay, understood, sir. Okay.
Coefficient of PL1.
Yes. Sorry, sir. Understood.
Okay.
Yes, sir.
Because see, in dynamic panel data model, my main focus is on that lag only. Na? That is creating all the problem, right? So,
Yes,
so we'll have to have a theoretical bound, upper bound and lower bound. So if your number is in between those two, upper bound and lower bound, then it is easy for you to defend, and you can always give the reference of the RL&1 bond because they are the opponent of this idea, basically.
Idea, sir. Yes, sir.
Okay. So then Buber, Bond and Buber and Bundel and Bond, they worked on their basic idea, right? But
Yes, sir.
basically, initially it came from them only, right? So
Yes,
they
yes,
just, improved that that instrument part. That in system GMM, what they did, they took the same idea and they told that why are you only restricting yourself to only the lag of the level variables as the instrument? You take lag of the difference variable also as the instrument, right? So then it became a system GMM, system of equation, both difference as well as lag. But idea is very much borrowed from Arellano and Bond only, right?
Okay,
So this is upper bound and lower bound, and you can remember like this which one is upper bound and which one is lower bound. I'm not getting into the derivation part of it because that is too demanding in terms of maths and all. So as far you can remember like this, or at least I remember like this, that in fixed effect model, we eliminate the fixed effects, right? That mu I or alpha I by differencing or by demeaning, right? Yes or no?
Yes, sir. Yes, sir.
So naturally it will be lower.
Lower,
Because
yes, sir.
I'm removing some part.
Yes,
And
sir.
in OLS, I do not do anything, right?
No.
So it will be more. So like this, you can remember. Correct?
Okay.
So which one is upper and which one is lower, right?
Yes, sir.
So once you run one model, you have to check that your the coefficient of the lag dependent variable falls in this range. If it does not fall in this range, then probably you'll have to work on some model specification because this is the theoretical bound that Arellano and Bond proposed, and that is quite acceptable. So it's like we check whether we are able to get the numbers in that range or not. If we do not get, we change some of the model specification and try to get the number within that particular range. Okay, clear? Fine?
Just one difficulty I have, sir. I declared panel data set. Then when I gave this lag value, it says the object P data not found in P.
So what you have to do here, you see here you might have given only P data only, right?
Yeah.
So here see the P data, but here this should be data. Please make sure that is correctly done. You have done this?
Data, yes, sir. Data, comma index.
But how come you are getting P data here in like this in the environment?
Sir, I'm not actually getting that, sir. If I type, there is an error.
Then there is an error. So first of all, your data is coming the way I have got.
Data has come, sir. Data has come. P data is not coming.
Then you do one thing first. Run the library PLM.
That has been done, sir.
Library PLM is done. Then you have run this code.
Sir, have you shared this?
I shared this code, na?
Okay.
P data, this one I have shared, right, in the chat, in the WhatsApp.
Yes, sir.
Yes
You
or
have shared.
no?
Yes, sir. You have shared.
Sir,
Please
I'm
run this
actually,
code.
yeah, I ran that, sir, actually.
So that got executed. That code got executed the way
Just
it is. Is it showing any error in that code?
so let me run it. Expected error symbol in P data, something it is showing actually.
I really do not know what is the problem. So your data import is correct, right?
Yeah, data import is right. Now I was able to do it, sir.
Mm-hmm.
Then I'll try to run it again.
Mm.
Sir, it has come, sir. Thank you.
Yeah. So
Thank you.
sometimes I do not know, software is like, so maybe we make mistake, but it is very, very difficult to identify where the mistake is, right? It all
The
looks
code
same.
is very sensitive. Very sensitive.
Very sensitive, because we may make mistake, but software will be very, very particular about it, right? If something is missing, it will not work. So, that's the problem. Okay.
Thank you.
So anyway, so now run these codes. I think it should come now. Okay. Done?
Yes, sir.
Copy and paste this part. Now we will run pooled OLS model. But when you run pooled OLS model, always add, this is by default, always do when you work on system GMM. It is kind of a unwritten rule that you have to have dummy, AR dummy, because that will help you qualify the AR1 and AR2 test. If you read the Rudman's paper on extra bond 2, which is the package or which is the package or library, what you call in Stata,
Package, sir.
package for running this system GMM and all those things developed by Rudman in Stata. So there, that paper, they have clearly mentioned that if you want to meet the AR1 and AR2 test, then you have to use the, you are more likely to meet those tests or qualify those tests if you have time dummies in your data. Okay. So even if when you decide the upper bound and lower bound, you should have the time dummy in your model, right? Yes or no? So what you do, my first model, I'm just giving you this model. First model, I'm just giving you. Is based on pooled OLS to decide the upper bound or upper value for the lag dependent variables coefficient, right? Just run the model.
Sir, are you using the that is the lag value of the regressors too? Like the independent variables, lag one of the independent variables. They are not contemporaneous.
Yes.
Okay, sir.
I have used, again, this is a very, very standard practice to, because please understand one thing. If you use the contemporaneous values of both
Yes, sir.
dependent and independent variable, the endogeneity that might come from simultaneity bias will be high, right? Yes or no?
Yes, sir. Yes, sir.
So to be on the safer side, it is always to work better to lag the, even otherwise the other independent variables also you should lag. This is a standard practice. Okay.
Yes, sir.
Correct.
Yes, sir.
Because see, if you use both, contemporaneously, then simultaneity is more likely. But if you lag them, then simultaneity is less likely. Correct.
Yes, sir. Understood, sir. Understood, sir.
Correct.
Yeah.
That's the point. So this is one trick to avoid simultaneity, endogeneity that might come from this thing, simultaneity bias. Okay. So what I have done, to first read, run the code, and then I'll explain the code. That is not a problem. You need to understand the code. So first, run the code.
So
if you
why
run the
only
code,
one lag if use one or the other lag?
which one? Lag 2.
Yeah.
No, lag 2 I have not used simply because if you give the command, then the command will take care of it, right? And I have created 2 lags just in case I need to do some experimentation. Suppose I'm getting some result which is not defendable using lag 1. That means I have lagged the independent variable by 1 year. No? So in that case, I might consider lagging them by 2 years. That's the point. That's why we have created 2 lags. Okay.
And please explain again this factor here.
I'm explaining. I'll explain everything, and when we go to the different GMM codes and so, there I'll also explain. Don't worry about it. So what we have done is, in this case, we have run the codes, right? So just take a look at it. I have used LM because LM is a free inbuilt function in R, so no package is to be installed, right? So LM for full regression. P is the dependent variable. Lag of P is the lag dependent variable. Lag of I is again the independent variable lagged by 1 year, and MLI lagged by 1 year, right? Plus I have taken all year dummies. So the shortcut for year dummy is what? Factor in bracket year, right? Factor in bracket year, right? If you want to create company dummy, then what you should do? You should write like plus factor in bracket earn, right? This is the shortcut. Instead of doing year dummy manually year by year, this is the shortcut that you can use. Okay, clear?
Yes, sir.
Yeah. And then data is equal to panel data because you want to apply this model on this data, right? Panel data. Everyone got this? And then run the summary and you should get the output. But in this output, I'm mainly concerned about what? This
KL1.
one. Yeah, PL1. This value, you make a note of it somewhere. It is 0.56 approx, right? 0.56. So this is the upper limit. 0.56 is the upper limit. Okay. This is the upper limit. Now, once you are done with this, then you can just for your own satisfaction, or rather for my satisfaction, I always do the plotting of the residual just to see whether this particular model is kind of acceptable, even if it comes to that level. But generally, it's not important. Only that number is important for this. I'm just giving it to you. Just in one go, you copy and paste and run it. So it will be helpful to visualize the residual plot. That's it, nothing else. Anyway, we do not plot, report these things in the research paper, right? For your own satisfaction, I think you can do that. Just run this and check how the plot looks like. But this is a good practice. You always follow this. It will be like, okay. And you will see that if you work on a large data set, most of the times you will be able to, get a good plot, right? Because of that asymptotic property I was talking about the other day, right? Okay, done up to this, everyone? Yeah. Fair? Yes or no?
Yes, sir.
Yeah. Next, what is the next thing? Now we will run fixed effect within group model, right? So I'll just give you the code. Fixed effect within group model. I'll just give the code in one go. So anything you can just take it. And then we will run one by. I'll explain the code also. Not to worry about it. So in R. Okay. So now do it. First run the codes and then I will explain what it means. Please run the code. Let me run also. I'll be Okay, this also looks better than that. But anyway, we are not going to be interested in these plots. What I'm interested in is,
Lower
first let
value.
me explain the code. Yeah. What is this code? Now I have used PLM because I am using fixed effect within group model, so that cannot be run with LM. For that, you have to use that LSDV approach. If you recall, we discussed those things, right? And same model, what we have done here, model is equal to within and effect is two ways. Why? Because I want to include the time dummy also, right? Yes or no?
Yes, sir.
Yeah.
But
Because
sir,
this
in OLS, okay, sorry.
in OLS also we have taken time dummy, that is
Sir,
factor here.
firm dummies were not included in OLS.
Yes, sir, yes, sir. The farm
So
dummies are
that
not
will not
included.
be included in the
Yes, sir, but in here, here we are
because
taking.
because what is the difference? In OLS we do not recognize the fixed factor, na, harm specific effect. In pooled OLS we ignore them, we let them be in the error, right? Yes or no?
Oh, okay, okay, understood, sir. Yes, sir.
Correct. What is pooled OLS? In pooled OLS
Assumption
we do
is
not
yes.
recognize the fact that each farm is different, right?
Yes. Yes, sir.
Okay, sir.
But in fixed effect we recognize the fact they are different, and that is why we first include them and then we remove them by demeaning or differencing, right? That's
Yes,
the
sir.
basic difference, right? But time dummy will be there in both the modes. Okay, clear? Parvinder ma'am, is it clear? You asked
Yes, sir.
the
Yes,
question.
yes, sir.
Yeah, okay, good. So now you have run the numbers, codes. What is the result that you are getting?
Sir, PL1 0.30 is
So
lower.
lower limit is approximately 0.31, right? If you round it.
Okay.
So just make a note of it somewhere. 0.31 is the lower limit and upper limit was 0.56, right? So you have to make sure that your estimates for the coefficient of the lag dependent variable lies in this particular range. Okay, clear?
Yes, sir.
Yeah, done up to this, everyone? Okay, yes or no? Please let me know if you have done. Now what we'll do, we will now get into the main. These two models are run just to figure out the upper limit and lower limit. Now, what next I should do? Now I should run difference GMM first, one step model, right? One step difference GMM model. But anyway, we will go for two step also, but I'll just show how to do one step and two steps, right? So for that, I'll have the codes. I'll just give it to you. First, you take the codes, and then can anyone is typing anything in the chat? Someone is sharing the codes in the chat also, is it? Yeah. Okay. Just run the codes, everyone. Should I check what is there in the chat? I generally do not check what is there. Oh, yes, sir. Someone is telling. Okay, good. So now you got the code, everyone, for one step difference GMM model. Difference GMM model. First run the codes, then I will explain. Run the code. This warning message will come, but no need to worry. This is not an error message. There is a difference between warning and error. Okay, this is not an error. This is an warning. So R is just warning. Oh, many times they keep giving you warning, but not to worry about it. Okay. Again, they are giving warning, but I'm not bothered about the warning. So just run all the codes that I have given, and then I'll explain the code. First code is most important. Okay. So you see, I'm pretty much getting the normality in most of the models. Now, once you are done, let me know. I'll explain the code. Once you are done, please let me know.
Sir, I have done. I don't know.
Then, what about others?
Yes, sir. Done, yes, sir.
Done? Okay, now look at this code, model 3. So we are using PGMM, which is part of PLM. So no need to install it separately, right? That is the function for panel data GMM, right? And this is the formula that is basically the model. So P is the dependent variable, lag of P1, first lag of P plus first lag of I plus first lag of M. These are the main variables. And after this symbol, whatever we have, these are all instruction for instruments. So I am saying for you use instrument of lag P, second lag to third lag, right? That's the instruction I'm giving. 2:3 means from second to third, right? And similarly for I, 2 to 3, for M, 2 to 3. Okay. You have flexibility of changing this based on the result that you obtain, right? Correct. And you might be thinking, sir, what about the differencing part? Automatically it will take care because of the codes. Data is equal to P data. Effect is 2 ways. Why effect is 2 ways? 2 ways because I am including both fixed effect as well as uh, time effect. So you just make a correction here, fixed effect plus time effect, because we are using in both the cases in everywhere. Just mention here if you have plus time fixed effect, because we have used 2 ways, right? Used individual fixed effect plus time fixed effect. That is why effect is 2 ways. Model is 1 step. Now here, what is this difference between 1 step and 2 ways? 2 ways determine whether you are taking both fixed effect and time effect or not. And 1 step is for your assumption of homogeneity of or homoscedasticity and heteroscedasticity. Related to that, you will either mention 1 step or 2 step. And then transformation, this is the point I was making. What is the instruction that you are giving for transformation? You are giving difference equation. Your instruction is difference. That means you difference. And when you use the system GMM, then you will what? Level
LD,
difference.
LD.
That means you want both the level as well as difference. Okay.
Yes, sir.
Clear?
Sir, I have a
Understood?
question.
Yes.
Sir, when we are using PGMM, then formula is equal to P. P depends upon lag P comma 1. That is the lag value, 1 lag of P.
Lag value of P. First lag of
Sir,
P.
sir,
Yeah.
why are we not writing PL1 when we have separately created the
No,
variable?
it's not. So those things I wrote for using them in that pooled OLS model. Because in this,
Sir,
it will automatically.
still those
No, no,
variables.
no. What
No?
I'm saying is, in the function itself, it will take care of it, because this is the structure in which it has to be written, right?
Okay. Okay.
Yeah. But this is not possible. This structure is not possible when you run pooled OLS, right? With
Right.
LM. So then, for that, so you need this lags, right? That's why we have created those lags, and here we can automate this.
The syntax of this GMM is just like that, so we
Yeah,
have to.
yeah, correct.
Okay, sir, got it.
Okay, so you can use it So if it is already automated, why to type manually in that case, right? Separately, yeah. Okay, understood. Got the point? Yeah.
Yes, sir.
Now transformation is D
So
means
please
difference.
explain effect model and transformation.
Effect means I am using two-way effect, two-way model. That means I have taken the fixed effect, individual company specific fixed effects plus time fixed effect, both. That is why it is two ways, right? And one step means I am assuming that there is, homoscedasticity in the variance. That's the point I was explaining, right? And transformation means transformation. How do I want the software to transform my data, transform my variables? By differencing, only difference. That is why D means difference. Okay, apply first difference transformation. Clear?
Yes, sir.
Yeah.
So where you wrote lags before pooled OLS, there you don't have the third lag. So, I mean, that's not connected with this formula P lag.
Which these things, these are
Yeah.
for instruments. These are for instruments. And
Okay.
in OLS, so there is no question of instrument. That is why.
Okay.
Clear? Because in OLS, in normal OLS, do we use any instruments and all? No, right? But here, when you use difference GMM, you will have to specify your main variable and also you'll have to specify the instruments. How, at which lag you want to instrument them, right? And because this D is given, so that they will take the differencing part. Because if you know in difference GMM, the basic equation is in difference form, first difference form, right? And then the instrument is in the lag form, lag of the level.
Yes, sir.
Like that. So this is how it is. Now summary of the results. You have run the model, I think, right? Everyone run the model. Did I give you the whole thing? I think I have given the whole thing, right? Till the residual.
Yes, sir. Yes, sir. You have given it, sir.
Yes. So just take a look at the output. Okay. What are the outputs that you have got? First of all, lag of first lag of P. How much is the value? Point
40, sir. Within the desired range.
within the desired level, right? Within the lower limit and upper limit, right? And you see all the variables are significant, correct? So here we can see that both the innovation and marketing efforts are impacting the profitability positively. That is what the data is showing, right? That means if you do more innovation and all, it impacts the profitability. Okay, so that's fine. Now,
Please explain within the range that you are talking.
range. So you have made note of that lower limit and upper limit, right? Upper limit was 0.56 and lower limit was 0.31, right? If I recall correctly.
Okay.
And what is the value that you have got for first lag of P? 0.40, right? This one.
Okay.
So it is within the limit, right?
Yes, sir.
Okay. Next. Now comes to the significance part. You all understand that is not a problem.
What this justifies if it is between the range, upper bound and
within range means it is easy for you to justify. Otherwise, you'll have to do some change in the specification of the model, right? Or you have to play with the lag structure, right? All those things. And now the rest of it, let me explain for at least one, then you can do the similar thing. So Sargan test, what is Sargan test? Sargan test basically tells you whatever instrument that you have used, whether they are valid or not, right? So null hypothesis is instruments are valid and your null hypothesis is accepted because p value is more than 0.05. Yes or no? See these numbers, correct?
Yes, yes.
So it means your instruments are valid, correct? Now comes, this is the first hurdle you must pass. Second hurdle is with respect to autocorrelation. And you know that since you have included the first lag of the dependent variable, first order autocorrelation must exist, right? First order autocorrelation must exist. That means this first order autocorrelation, this value must be statistically significant. right? And is this value statistically significant? Answer is yes,
Yes, sir.
because
Yes.
1.33 to the power of divided by 10 to the power of 8 is almost 0, right? So first order autocorrelation is there. So I have qualified that test. Okay, first order autocorrelation is significant, and second order autocorrelation must not be there, should not be significant. So here, what is the p-value? P-value is 0.62. It means second order autocorrelation is not there. So my model is perfectly fine. I have qualified the instrument validity test as well as AR1 and AR2 test. Clear? Everyone understood? And this is the best part of the difference GMM and system GMM model, because in the output itself you have the diagnostic check, which we need to do separately for fixed effect models, right? We run those diagnostics separately. But in this case, in the basic code itself, it will show you the diagnostics. And if you do not fail, then you have to change the model or change the model specification, right? Is it clear, everyone?
So once again, this autocorrelation.
Now, autocorrelation part means, since we have included the first order, since we have included the first lag of the dependent variable as regressor, there has to be correlation between first order autocorrelation, right? That means at lag 1, there should be correlation, right? And we can see that there is correlation because it is statistically significant, because p-value is less than 0.05, right? Can you see that?
Yes.
Yeah. And second order autocorrelation must not be there. Means second order autocorrelation should be insignificant, right? So how do you decide whether it's something, any p statistic or any stress statistic significant or not? If it is less than 0.05, then it is significant.
Yes.
If it is more than 0.05, then it is insignificant, right? Correct?
Yes. Yes.
Got it? Yes.
Yes.
And then comes wall test for coefficients.
Sir,
That means this tells you the overall whether jointly coefficients are statistically significant or not. And they are significant, right? Because p-value is again less than 0.05. And you know how to convert these numbers. If you put them into Excel easily, you can convert 7.28 divided by 10 to the power of 11. So it will be very, very close to 0, right? And wall test for time dummies, whether time dummies are statistically significant jointly. Yes, they are also jointly statistically significant, because here also p-value is less than 0.05. Okay, everyone understood how to interpret the output? Each and everything I have explained. Okay,
sir, I have a doubt.
yeah, tell.
Sir, I understood that the first order autocorrelation should not be first order autocorrelation should be significant because it is acting as a independent variable for the model, right?
Because we have included first lag of the dependent variable.
Yes,
So
sir.
because
Yes,
of that, there will be autocorrelation. Yeah.
yes, sir. And why second? Okay, second order autocorrelation should not be significant.
Because see, if you do
Just like
not include, just a minute, let me explain, you will understand. If you do not include the first lag, then what is the condition? That even first order autocorrelation must not be there, right?
okay, got it, sir. Got it. Clear.
So if you include first lag, then you are okay to have first order autocorrelation, but from second order onwards, autocorrelation must not be there.
Perfectly clear, sir. Perfectly clear.
So that's what it is. Because if you don't have that lag, then you are not even allowed to have first order autocorrelation. But if you have that lag, then you are allowed to have first, because you have included it. So definitely it will be there. But from the next lag onwards, there should not be autocorrelation. Right. That's the point. Okay.
Sir, wall test is telling the joint significance. So, first wall.
Joint significance. Joint significance.
So first,
Joint significance for all coefficients is significant. Similarly, joint significance of all time dummies is also significant.
Okay.
Okay. Okay. Clear. So now we can move little faster because we have explained everything for this model. Now let us go back to the second model that you will do in difference GMM, that is 2-step, right? So one step is done. Let us go to 2-step. And one more thing I wanted to tell you, which I forgot. Where is the output? My output is here, right? See, this Sargan test, this value, p-value, if it is say 0.98, is it good or bad?
It is not statistically significant, but it may lead to overfitting, sir.
Please, this is a point. If your this p-value for Sargan test is somewhere around more than 90%, 95%, then your paper will not be accepted, because reviewers will question that it is a case of overfitting. So ideally, in good journals like in A and above, they want your the Sargan value to be in the range of 0.1 to 0.4. This is a rule of something that they follow. But in general, in not so good journals, say B and all, they accept any number within say 0.1 to 0.8, they won't question. But if it gets to like 0.9 and more and all, then it will be very difficult for you to get it through. You'll have to modify your model or do something to bring it down, right? So because those high value represents highly overfitted model. Because why this is not accepted? Because since these are instruments, so it cannot be exactly equal to 1, right? Yes or no? Think logically. If you are saying it is exactly equal to 1, I have found one instrument, and it cannot be exactly equal to 1, because it is all instrumented by lags. That too, lags of label is being used to instrument the lags of difference, right? So how come you are claiming that your fit is almost 100%, 99%, 98%? So those are false claims, right?
So it is
So
only possible for time invariant variables, might be, na, sir? Because if the variables are not changing, instrumental variable lags are same, then also it
so
cannot.
then though there is no question of anyway. Time invariant will anyway will be wiped out now, because differencing
Yes,
is
sir.
being
Yes,
done,
sir.
right?
Then though
Correct.
it is not possible. Yes, sir. Yes,
Not
understood.
possible. So naturally, if you get something in excess of 90% or something, the people will question about it, right? And you are not even using external instruments. So if you use external instruments, still we can make some sense that it could be 90% close. But with this, it is very, very difficult to defend. So ideally, as I told you, there is no hard and fast rule, but 0.1 to 0.4, if you get, then you can get your work published in good journals, right? So is this point clear to everyone? Yes or no?
Yes, sir.
Yeah. So let me now close this and go to the next model, that is two-step. So what is this two steps model code? Now we will write two steps. Here also it is plus time effect, plus time effect, time fixed effect. Okay. So we will just run this. I'll give the code to you. Please run. So let me put it in the WhatsApp group. Please do it, everyone. Let me... Running the library is a good practice, because in R, one more thing you keep in mind, if sometimes there might be some errors, you in those cases you run all the codes from the beginning. So that also helps at times. Okay. So we have run the model, and okay. And rest of the things we just quickly do it. Density plot. Okay. Now, once you are done, just come back the code and understand what's going on here. So this one I have done one step system GMM. Is it? Oh. Which one I have given? I have given two step to you. Yes or no? Two
Yes,
step
sir.
difference GMM.
GMM you have given, sir.
Two step
He-
GMM.
Different
System.
GMM. Yes.
Difference I have given. Na? Okay.
Yes, yes, sir.
So this is run. Okay. So are you done?
Yes, sir.
Yes, sir.
Okay, so it looks perfectly fine, no issues, I think. Now, come to the code. Now you see, what is the change basically I have made? I have made this change, everything else same. Effect is 2 ways and model is now 2-step, right? Yes or no?
Yes, sir. The model is changed. All the things remains.
Everything else is same, only model is changed because that was 1 step, now it is 2 step. Okay? Yes or no?
Yes, sir.
Okay, now do one thing. What is the output of this 2 stage? Just take a look at the standard errors here. Vis-a-vis the standard errors of the previous thing, 1 step. 1 step, compare the 1 step standard error with these standard errors. Just check everyone. These are 0.8, 0.8, 0.4. So what was the other thing?
Does
2
it gone up,
ways,
sir?
1 step. So here you see these are lower, right? In 1 step, it was lower. These were lower, right? Standard errors.
Yes.
You are considering system GMM, sir. I guess the model that you have, it is like, yes, above this, yes, sir. That is the model of difference.
Yeah, this is the model, right? So there also you see these are lower, right? Yes or no?
Yes, sir. Yes, sir.
These are 0.8, 0.8. So ideally, this should be lower because in 2 step we are using what? Heteroscedasticity assumption, right? Yes or no?
Yes, sir. Then we are more like
So robust standard errors. That means what is robust standard error? I told you we increase the standard error, right?
yes,
We
sir.
penalize it. If we
Yes,
increase the standard error, what will happen? The t value will come down or z value will come down. If z value comes down, then the statistical significance possibility will go down, right? Yes or no?
yes,
Yes.
sir.
Yeah. So that is the concept I explained the other day. Now, are you able to connect the dots? Yes or no?
Yes, sir.
Yeah. Okay, so rest all are same, the interpretation. You can see whether I am meeting all the other assumptions, other diagnostic tests. I think I am meeting all those diagnostic tests, right? Yes or no?
Yes, sir.
Now,
Yes.
in this case, you see I is not significant, but that's not a problem. My Sargan value is 0.41, perfectly okay, no issues. Autocorrelation 1, order 1 is there. Order 2 autocorrelation is not there. And the overall joint significance of coefficients and ER dummies both are significant, right? Okay. So
Yeah.
no issues as such. And what is the value that I have got? 0.35, right?
Again,
So what was the lower limit? 0.31, right?
3-1, 3-1. Yes, sir.
So we are pretty much there.
in the
Okay.
range.
So this was 2 step. Now Akriti asked me one question that the way we had system GMM for fixed effect and random effect model, we had something called Haussmann test to decide which model to go for. So similarly, for this this system GMM and difference GMM, there is a rule of thumb proposed by Arellano Bond that if your system difference GMM estimator is close to or below the fixed effect estimator of that coefficient of lag dependent variable, then your difference GMM is biased downwards. Okay. And system GMM is preferred. I repeat. Akriti, are you making note of it? Hello.
Yes, sir.
So when your difference GMM output, that is the coefficient, which is lower or close to the coefficient thrown by the fixed effect model, then difference GMM is downward biased. And decision is you have to go for system GMM. So what is the decision here? What you should go for? Ideally, if you have to compare between system GMM or difference GMM model, your value for this is 0.35, right? And what was the value for fixed effect that thrown?
Q1, sir.
0.31.
Yes, sir.
And for OLS it was 0.56.
Five
So
six.
it is closer to fixed effect model, right? Fixed
Yes,
effect
sir.
model value. So it means difference GMM is downward biased, and you have to go for
System GMM.
system GMM. And
Understood.
invariably, most of the cases, you will get system GMM as the verdict, the way we get in
Fixed
most
effect.
of the cases fixed effect.
Yes, sir.
Because system GMM is much more robust and efficient. Why? Because of the way we use the instruments. We not only use the lag of the level variables as instruments, we also use the lag of the difference variables as instruments. Right? So that's the verdict you are mostly going to get. Even if you do not report this, by default, system GMM will be preferred. Clear, Akriti? Is this concept clear? Yes or no?
Yes, sir.
Yeah. Okay. So now, now these are the things I think if you just read books, probably you will not get. But if you read research papers, you will get. Especially the Arredondo Bonds paper, if you read, there you will get some hints of all these things. And if you are working on Stata and all, then that Rudman's paper is very good, and extra bond too. But provided you are working on Stata, but let me tell you one thing: Stata is the best software for panel data econometrics. There is no doubt about it. Though I work on R, but Stata is far better when it comes to, especially this system GMM and all those things, reporting part. It's very good. The only problem is it is very costly, right? And for personal work it is okay, but in workshop and FDP, you understand what I mean, right? So it's not right to do those things. So, but R is still fine, but it has some limitation when it comes to. In R is stronger in some other domains. Really, in time series, it's very good, but in this thing, there are some challenges. Yeah. And you can see that the way the reports are reported, right? In Stata, it is much more organized in tabular form. And here we have to do extra effort to arrange and all those things and then take them to the Excel sheet and all those things. So you can understand that. But if you are working on Stata somehow, or you have worked, then you can read that paper written by Rudman on this extra bond 2 command, which is generally used for system GMM and all those things. So that is very, very flexible and lot many things can be done. Okay. So I have this up to this, everyone is clear about it? Yes or no?
Yes, sir.
Understood?
Yes, yes.
Okay.
Yes, sir.
So now let us quickly finish the system GMM part, and then we will also run the model. It should not be a problem. In next 15 minutes, we'll cover all these things, and then we will take up if there is any question or anything. Okay, so let me go back to the PPT again. And did you understand all those things, whatever we have discussed? Yes or no so far?
Sir,
Yeah,
we can
no
only
challenge?
have downward bias. We can have upward bias also.
So then, if you are having upward bias, then your system difference GMM is okay. You need not go for system GMM, but you will rarely get that. Okay.
Okay, sir.
Generally won't get them. But I am not saying that it's not possible. It is possible, because it is possible mainly in some cases when the data does not show much of heteroscedasticity all. So in those cases, in small samples, you can still have different GMM as the preferred thing, right? Sometimes it happens, but mostly it is system GMM. Okay. So what is the main problem with the difference GMM? The main problem with the difference GMM is I'm using the lag of the level as instruments for the lag of the difference thing, right? That's the thing. But if the variable, if the dependent variable is highly persistent, what do I mean by that? That its lag is strongly impacting its current value. Then the possibility is there that the lag could be, the lag of the level variable could be possibly correlated with the difference of the variable, right? So in that case, so it's not very common, but possibility is there that it may not be a very good instrument. right? So that's the only problem that we often talk about it. And if that is the case, it is only when the variable is highly persistent. Dependent variable is highly persistent. In that case, your lag of the level variable which you are using as instrument can be correlated with the main variable, because that one of the things, what is the one of the conditions of a good instrument, that it must be correlated with the independent variable which is endogenous, but it must not be correlated with the dependent variable. But if your dependent variable is highly persistent, then lags are having strong correlation with the dependent variable, and lags are being used as the instrument. So in that case, the instrument may be weaker. That's the only problem. Is this point clear to everyone? Yes or no? Is it clear? Hello?
Yes, sir. Yes, sir. We were writing.
Now, should I repeat it once more?
Yes, sir. I'm writing actually. So,
What I'm saying is, in difference GMM, what is being used as instrument? The lag of the level variable is used as instrument. That means yi t minus 2 or yi t minus 3 are being used as instrument. Yes or no? Okay. And
Yes,
what
sir.
is the endogenous variable? Endogenous variable is y delta yi t minus 1. Right? Okay. When the dependent variable is highly persistent. Highly persistent means what? Its lags are having very, very strong, high correlation with the current value. In that case, those lags are expected to have strong correlation with even this number. Yes or no? So if that is the case, then this may not be, then the lag of the level may not be a good instrument. It might be a weaker instrument, right? Is this point clear to everyone? That is what they are saying, basically. Have you understood? Hello?
To be honest, sir, I didn't get it, sir.
I know. I'll explain once more. Please listen to me carefully.
Okay, sir.
What is meant by highly persistent variable? What is meant by highly persistent variable?
when the lags of dependent variables are strongly impacting the current value.
Right? So it means what? The lags will have strong correlation with the current value, right?
Yes.
Yes, sir.
Yes or no?
Yes, sir.
Now, what is the condition? One of the conditions for good instrument, that it should not have strong correlation with the dependent variable, right?
Yes, sir.
But it should have strong correlation with the
Endogenous variable.
endogenous variable. But you are using instrument which are what? Lag of the dependent variable.
Yes.
Yes, sir. Oh,
And
yes,
if
yes.
the
Understood.
dependent variable is strongly persistent, then
Then
those lags
obviously
can have strong correlation with the
dependent variable.
dependent variable. So that
Understood.
makes them weaker instruments. That's what I'm saying. Is it clear?
Yes, sir. Understood.
Yes,
Understood, sir. Now it is
Yeah,
clear, sir.
that is the clear. Little tricky, but you have to just close your eyes and think, because these
Yes,
are
sir. Yes.
very
Now
tricky
understood,
and
sir.
advanced concepts, right? So
Yes,
if
sir.
you just simply read, you won't understand. You have to absorb it. Correct?
Yes, sir. Yes, sir.
Yeah. Okay, so that's the point. So how do we overcome this? We can overcome this with system GMM. Because in system GMM, we do not restrict only to lag of the level variable as instrument. We use lag of the difference variables also as instrument. So we have a system of instruments, or we have two equations. One equation is at level, that is y, x, like that. And one equation at difference, delta y, delta x, like that. Okay. So we combine both and we have a system of equation, and hence it is called system GMM. Rest all is everything same. And please understand, see, we are not only good copy masters, even economists are also copy masters, right? So they borrowed the idea from, Arlando and Bond, right? And then later on, Gundel and Bond, and uh, Gundel and so Bond and Buber. So they just improvised on it. and improve that version and give a better model, right? That's the only thing. But rest all are everything is same. That here also you need to have lag dependent variable. You must have endogeneity issues, and obviously unobserved fixed effect should be there. If unobserved fixed effect is not there, then there is no point getting into panel data model only, right? We can do what? OLS, pooled OLS only is more than enough, right? Because there is no unobserved fixed effect. Correct. So rest all are same. So this was introduced by Blundell and Bond. So Bond is a very, very critical factor in figure in this econometrics field, especially in this area, right? So as I told, that they improved on the difference GMM by increasing the efficiency and addressing the problem that might arise, as I just said, when the dependent variable is highly persistent. Okay, is it clear? Can I move to the next slide? Because nothing new here. Everything is same. Only they have improved that thing that and here is the thing. One is the difference equation. One is the level equation. See, this is the difference equation I was talking about. This was there in this difference GMM, very much there. Yes or no? Same thing. And instead of in addition to this, they are also having this. Correct? One is level, that is yx, and one is delta y, delta x, and definitely the lag dependent variable will also be there. Now, by combining these two systems of equation, that is difference plus level, we have system GMM that comes with improved efficiency by using additional instruments from the level equation and handle persistent variables by providing better estimates when y is highly correlated over time. So in case of difference GMM, I did not have any option to choose the instrument variable other than the lag of the dependent variable, because that is what was proposed by Arelando and Bond. But here, Ulundel and Bond, they told no, you have the flexibility to use even the lag of the different variables as your instrument. Okay, so that gives you much more flexibility, and because of that, your efficiency improves. Okay, that's the basic idea behind this. So here also 1 step and 2 step, what is the difference? No difference. The same difference as I explained in case of difference GMM, here also it applies. So 1 step, when I talk about, it is basically assuming homoscedasticity. 2 steps means assuming heteroscedasticity and robust standard error. Okay. When to use system GMM? Nothing different. It is similar to difference GMM, dynamic models, short panels, endogeneity issues, right? Okay. Now, if you just compare difference GMM and system GMM, in difference GMM, we use only the first difference. In system GMM, we use first difference as well as level, right? Instruments are lagged as instruments for difference variable. So difference variables are instrumented by the lag of the level variable. And in system, lag levels and lag differences, both are used as instruments. See this, lag levels and lag differences, both are used as instrument. In this case, only lag levels are the instrument for difference levels, right? Less efficient, this is more efficient. This is best for short panels with weak persistence. If persistence is weak, because if persistence is weak, then the instrument will be stronger, right? Yes or no? In case of difference GMM, if persistence is weak, then the instrument will be stronger, because we told that if the strong persistence is there, then the weak instrument will be weak, right? So short panel with weak persistence, you would prefer difference GMM. Short panels with high persistent variable, you will prefer system GMM. And you see that here system GMM will score more than the difference GMM. Why? Because first place, why are we using dynamic model? Because the variable is persistent. Yes or no?
Yes, sir. Yes, sir. Then
why are you using dynamic model? Because I think that current value is impacted by the
by
past
the
value. That
earlier
means
value, yes.
persistent.
Yes, sir.
If it is persistent, then system GMM is better than the difference GMM. So
Yes, sir.
naturally, the natural call will be system GMM, not the difference GMM. Okay.
Understood. Understood,
Is
sir.
it
Yes.
clear? Understood?
Yes, sir.
Okay. So now let us quickly run the system GMM models, and then we will stop. Okay, so let us go to the system GMM models. Are you able to understand? I know these are little heavy stuffs, but I'm trying my level best to make it as simple as possible, right? Okay, hope you are understanding. Correct. So one-step system GMM, I'll give you the codes. I did not get any reply on that. Have you understood so far broadly?
Yes, sir. Yes, understood, sir.
Okay. You can always read a book. I think you will faint in some cases because the notations are so scary. I mean, it's really tough to absorb. Math part of it is quite scary. Okay, so I have copied this. I think copy and you always again go through the video once the recording is shared, because you need to imbibe this. It take it requires some time to absorb whatever we have discussed today. So go through the video again and again, and next class when we meet, you can ask me if you have any doubt. Okay, so I have given you the one-step system GMM, right? So just run the codes. Okay, so rest all just run quickly. Okay. Okay, now once you are done, please let me know. You see, are you done?
Yes, sir.
You see, I have changed this lag structure to 2:2. That means I'm talking about only 2, not even 2 and 3. Why did I make this change? Can anyone tell? If you try with 2:3, see what is happening to Sargan number. Let me try this, huh? Just change this 2:3. Right? So everything is same. Then if I run the model, your Sargan test is showing p-value of 0.92854, which is more than 0.9, right? Yes or no?
So that means instruments are not valid.
No, it valid, but it is overfitting.
Overfitting. Okay. Okay, sir.
So this is difficult to defend, right? And that is what I meant. When you are getting this sort of numbers, you have to play with the lags to get a number which is acceptable or defendable. But if you change this to 2:2, that means you are restricting only to lag 2 for instrumentation purpose, right here. And obviously, it will take both the difference and the level as lag, because that is by default inbuilt. Because if you are doing, I'll talk about that code. That is not a problem. Okay.
Sir,
And if you run,
since you have said that you just want to restrict that lag to 2 only, then why haven't you used only 2? Why is 2:2?
no, because this is how the syntax is made. See, 2:3 means 2:4 you can make. So if you want to keep only 2, then it will be 2:2 only, means 2:2. That's how the structure is. That's it.
Okay.
Okay.
Understood.
Now see the code. Rest all is same. Now you see, after I make this change, my Sargan is quite acceptable. It is 0.28. It is very good, in fact, right? 0.1 to 0.4, right? And here, what is the change that I have made? Effect is 2 ways, everything is same, model is one step, and transformation is, instead of D now, LD. That means I have both L and D. That is level as well as difference. Clear? Yes or no?
Yes, sir. Yes, understood, sir.
Others, I'm not getting any response from others. Is it clear?
So please
Yes, sir.
explain
Yeah.
to
Which point you want me to explain?
2:2.
2:2 means I am restricting only to lag 2 because the structure is like that. 2:3 means 2 and 3. 2:5 means 2, 3, 4, 5. But if I want to restrict only to 2, then it has to be written like 2:2. And why 2:2? Why not 2:4? If you make 2:4, that number you will even go up. You try that. If you make 2:4, it will be somewhere around 99% or 98%. So then you are in the big trouble,
Okay.
right?
Okay.
So this is a trial and error approach. You have to make sure that, because this is the best part of system GMM or difference GMM, because you can see the diagnostic right there, right? So you can change. You don't have to run this diagnostic separately, right? Okay. In Stata, instead of in addition to Sargan test, it also reports Hansen test. So which is considered little more standard or robust than Sargan test, but as long as you are getting a good number in that value, so it is not going to be. But if you are somewhere in very borderline, suppose your value comes to somewhere around say 0.5, 0.06. So at 5% level, you are still accepting the null hypothesis that instruments are good, but it is on the borderline, right? So in that case, you also have to report, probably reviewers might ask you also report Sargan, Hansen test. Otherwise, it is fine. Okay. And in R, it is not reported separately. So it has to be a separate command altogether. And I think in GMM, GMM package, it is there separately. In PGMM, by default, they use Sargan. But in most of the cases, because anyways, you will be ensuring that it is within the acceptable limit, right? And if it is in the borderline, anyway, you'll have to work on the model and improve it further, right? So there is no issue with that. So you got it. So explanation part, everything you see, I'm meeting all the assumptions as we did earlier, right? So same assumptions and same diagnostics. So now let us go to the final plot for the day. That is 2 steps system GMM.
Sir, again, I have a doubt.
Tell.
Sir, what about the coefficient of dependent variable lag? Do we need that is simple coefficient? We do not have any upper lower bound in this case.
So it is there. No, what is the answer? 0.45. So it
So
is
that
within
is
the
the
limit.
answer.
Within the limit.
So again,
The-
we have to compare it with the limit, just like before.
limit. It should be within the theoretical limit. If that is not the case, you have to modify the model, right?
Okay,
Okay.
sir. Okay.
Within the limit. What was the limit? 0.31 and 0.56, right?
Right, sir. Right.
And now we are getting what? 0.45. It's okay, right?
Right.
So next is the last model that we will run for the day. That is 2 steps system GMM. And I'll just put it here. So quickly run. We have shared. So here in all these cases, please add time effect also, because I typed it, copied and pasted. It's the same thing. So here, since it is 2 effect, 2 OS, so always time effect is also there. Time fixed effect is always there, right? Time fixed effect. So same copy and paste error. So let me run this and see what is happening. Okay.
P value of Sargan is 1 now.
Sargan value is 1 here.
So now you have to make some modification here. So you try 3 and check what is happening. Okay, 9-8. So most probably we should go for 2-2, right? Because in one step also that was the case. So this is the modification that you have to make in your lag structure to make it to acceptable level. Okay, 4.8. Now it is, I think, manageable. Yes, correct. Okay. So you see your coefficient is also 0.42 within the limit, right? And Sargan is also 0.48, easily defendable, not a problem, right? Rest all are okay. Your autocorrelation, first order autocorrelation is done. Second order autocorrelation is not there, right? Your joint coefficients, significance there. Time dummy significance is also there. Rest all are okay. Okay. So you got idea, right? How to run these system GMM and different GMM models. So